Today, as part of solving the problems from the blind 75 list, a list that cover most of the coding problem patterns, we are looking into the following problem. Contains duplicate problem. Let's see what the question is asking. So what they are giving us is an array of integers that's called num. And then what they want us to look into is that to see whether we see an element that at least appears twice. And if we can find that an element appears at least twice in an array, we want to return true. Otherwise, we want to return false. To understand this better, let's look at an example. So here we have example 1. We have 1, 2, 3, 1. So we see that 1 is repeated twice here. So the output is going to be true. The return type is a Boolean. So basically the output is true. We want to return a Boolean. So either false or true. In this case, we return true because 1 is repeated twice. And that's the condition for the true response. So if any value appears at least twice in the array, we want to return true. Example 2, we see 1, 2, 3, 4. And basically all the elements they appear at most once. So they don't repeat. As such, we return false. So that's the problem. And then let's look at the constraint here, which are pretty like standard. Basically, the length of the array here is going to be from 1 to 10 to the power of 5. And the value of each element in the array is going to be, it could be as little as minus 10 to the 9 or as big as 10 to the 9. So basically, pretty standard constraint. Nothing too scary. When we are trying to solve the problem, and specifically in regards to the constraint here, since we can have many numbers like 10 to the 5, it's still a large number. Basically, we want our solution to the problem to be efficient. And that is why we should use a data structure, or basically data structure make our problem like, or our solution, like, when we're trying to find a solution to this problem, is that our solution should be efficient. We cannot provide a brute force solution, specifically with regard to the constraint, because the number of elements in the array, as we see here, they can be quite large, like 10 to the 5. That's a big number. So our solution needs to be efficient. And that is why we should use some kind of data structure. And in this case, that data structure is going to be a hash set. Now, why a hash set? Let's see what is exactly a hash set. So basically, the definition for hash set is that it's a data structure used to store a collection of unique elements. And that's the key here. The elements are unique. So what are the characteristics of this hash set? They cannot contain duplicates. If you try to add an element that already exists, the set remains unchanged. So that is pretty useful. So basically, we cannot contain any duplicates. And they are pretty efficient. And that's in what mattered most in our case, is that they're efficient. It provides O1 or constant time average complexity for basic operations such as adding, removing, and checking if an element exists. And that's what we want to see. We want to check if an element exists, and that's going to take O1. And this is the key to solving the problem. Let's go into coding now. Let's start with the hash set. Let's declare a hash set. So val, let's name it my set equal to hash set. And here the type is going to be integer. So that's our hash set. Then we want to loop through the array. We have our hash set now, and now we want to loop through the array. So we're gonna use a for loop. We're gonna name our variable. We can name it anything. Let's put n as number. So for n in nums being our array, we're going to iterate. So what we want to do, so we have my set. So first we want to check if the number we are looking into, we want to check if it's present in the set or not. So we're going to do if, we're going to use an if statement. So if n in my set, that's how we check to see if an element is in my set. And remember, this is gonna take on time, o1 time, constant time. Again, this is gonna take on time, and that is why the solution is efficient. This lookup is gonna take only o1 time, basically constant time. So if n is in my set, what do we do? What does it mean if n is? It means it has already been there. It means it's a duplicate. So what do we do here? We basically return true because we made the condition return true. We found out that this array contains duplicate. Otherwise, what happens is that this part of the code is gonna get executed. So if this condition doesn't hold, what we want to do is that we want to add the number to the array. So we have my set that add n, and we're going to continue looping. And if we get out of this loop without having returned true, it means there are no duplicates. So we're going to return false. Return false. Now let's test this solution. Let's see the basic solution. So we're going to run it. Return, this is a typo, false. So we're going to run it again. So we pass the test cases. These are the basic one. Let's see if we submit what happens. This is the most important part because we're going to have many test cases and it's going to be tested against, like here, against 77 test cases. And if it passes, it means the solution is good. So it passed it, the solution is good. It beats 70% of the other solution. The runtime is 21 milliseconds, so it's pretty efficient. And basically that is the solution to our problem.